on. All right, so. Okay, so the first thing you want to do when you have this question or this kind of question is go to, make sure you add the frequency, the total number. So add the total number. Okay, so add the total number. Let's see, grab this, get out of my way. Okay. So okay, so the first thing I want to do is go to my, and the best thing to do actually is get your calculator. The quickest way to solve a problem like this. I know we have done this kind of thing, but I know what is in the test. That's why I want to make sure if there are 15 questions, you don't miss an obvious question, something you should get right. So the best approach to this kind of question is go to stats, put your random variable in L1 and put your frequency in L2. So which means it's like you are doing a group data. That's what it looks like. So this time I'm going to put in the random variable 4, enter, 5, enter, 6, enter, and 7, enter. There are 4 of them. And then I'm going to put the frequency in L2. So the first frequency is 18. The other one is 21. The other one is 21. And the last is 35. And then the question is going to ask me to find, okay, let's see what the question says. It says find the probability. Okay, you already know that probability is the same as relative frequency. That's what you already know. So if you're doing it by hand, you add all the frequencies, but you're not doing it by hand. So add all the frequencies and divide each by the total. But this time I just want to go to start and one variable start and do one variable start of a group data. One variable start of a group data where the random variables in L1 and frequency is in L2. Okay, go ahead. Back to, so because I have frequency in L2, I put frequencies in L2 and I hit enter. All right. Total frequency is actually the sample size or the number of frequencies is 95. Is that clear? The number of frequencies is 95, which means that is what you're supposed to write here. So the total frequency is 95. Let me write it here. Summation frequency is 95. Even if you're told to list each one of these, all you have to do is, this is 18 divided by 95. If you're told to show, you can still show. You can show it in decimal, you can show it in fraction. And this one right here is 21 out of 95. And this one right here is 21 out of 95 again. And this one is 35 out of 95. Because you're told to find the probability or relative frequency. Now, the next thing is you could be told to find the mean. Well, remember that the mean of a discrete probability distribution is n times p, sample size times p, but you have to add, so summation of each n random variable multiplied by the probability. So this multiply this, but you're doing it with a calculator, so it's going to do it for you. Each random variable multiplied by probability. So when you finish, you add them up, all of them. So EX1 to P total, and that is when you get the mean. So the mean of a random a probability distribution is also called expectation. So the question can say, find the expectation. Find the expectation. Expectation is the same thing as the mean. So if you're told to find the expectation, it means find the mean. All right, but I'm using my calculator, and my calculator knows how to find the mean, provided I tell my calculator that I'm doing one variable start with a grouped data. Provided you feed your calculator that this is a grouped data. Okay, so now that I told my calculator that I'm doing a group data and I want the mean, it will tell me that the mean is, by the way, I have to check and see how many decimal places. If it tells me to find the mean to 2 decimal places, somebody give me the mean. Somebody give me the mean to 2 decimal places. The expectation, what is it? What is the expectation to 2 decimal places? 5.6, okay, 77 is correct. If you're told to leave the mean to 3 decimal places, it becomes 5.768 and so on. So you have to be careful the number of decimal places. Okay, so construct a discrete probability distribution. Of course, if it is a discrete probability distribution, the sum of all the probabilities must be 1. The sum of all the probabilities must be 1. Okay, I'm talking about all the probabilities right here. Okay, and then you could be told to graph each of them because it is a discrete probability distribution. It is discrete. You don't join. You just graph the lines. The maximum probability is approximately, it's not going to be up 0.5. So you make sure you are drawing a line to the end. Draw a line to the end. Is there any question on that? All you have to do is you want to find this to maybe 2 decimal places or 1 decimal point. And by the way, just in case you want to use your calculator, just in case you want to use your calculator to find the probabilities, let's make sure you know how to do that though. Let me make sure you know how to do that. Okay, if I want to use my calculator to find the probability, all I have to do is go back to Start, Edit, arrow to L3, and go to the top and say, in other words, tell your calculator to add, multiply, see, what you are looking for is the probability. Okay, so you want to multiply each random variable and then you add them. First of all, you divide it by 95. You divide it by 95. It depends on what you are looking for. If you want to check that all the probabilities are equal to 1, then you do L3 divided by 95. Okay. That is, I hope you know what I'm talking about. Suppose I want to find all the probabilities. I don't want to, I know how to use my calculator. That's the most important thing. So I'm going to do, okay, this is L2 divided by 95. So second L2 divided by 95. In other words, each individual frequency divided by total frequency. That's what I'm trying to talk about. So you can actually fill that column. Do you understand what I'm saying now? So you got your probabilities. Okay, so now you have the probabilities And you see that the maximum probability is 0.336. And so when you are graphing, this will help you to graph. So when you are graphing, or the graph is already drawn for you, the x-axis is the random variable, the y-axis is the probability. This is a probability distribution. So you must choose the correct graph, because you know that the maximum probability is 0.36. You better not, the maximum is 0.36. So you are checking to make sure that the one you choose is the correct probability. And then let me see, what other question will you need to know now? What else? Is there any other question you want to know from there? Okay, well, let's go down and see what the question says. Find the mean, compute and interpret the mean of the random variable x. So we already know that the mean round to 1 decimal point. So we already know that the mean is, okay, let's go back and find that mean. I do one variable starts. Don't forget that it's one variable start of a group data. Do not forget that is one variable start of a group data. So L1 and L2, then you calculate. So let me calculate now. L1 is now is random variable frequency is in L2 calculate. And so the mean to 1 decimal point is 5.8. I'm told to find the mean to 1 decimal point. I want to answer the question to accuracy for 5.8. That is the mean. Well, let's see if they have, okay, well, this is interpret the mean of the random variable x, select the correct answer. Select the correct answer, or choice below, and fill in the box within your choice, round to 1 decimal point. The series, if played many times, would be expected to last about, on average, last about 5.8 on average. The series, if played one time, no, several times. If you continue, if you do a lot of repetitions, then the average, the mean, or the expectation will be 5.8 if you do it several times. Just like if I throw a coin several times, a fair coin has head or tail, and the expectation will be 1/2 for tail, 1/2 for head. If I throw a fair coin maybe 1,000 times or 100 times, after some time, the expectation will be 1/2 or 0.5, because you have a lot of repetition. Something called law of large numbers. The law of large numbers says that as you do a lot of repetitions, the random variable gets to the actual mean. It's called law of large numbers. Maybe not as when it gets to stat 2, then you're going to use law of large numbers to do a whole lot of things. But for now, we don't have to make a big deal out of it. Okay, let's go to D. This question has D part. I know somebody told me that we have done this before, but I want to make sure that we emphasize what we need to know. D, compute the standard deviation of the random variable. Somebody tell me how to get the standard deviation of this random variable. Somebody tell me, how do I? In fact, some questions will ask you to find the variance. How would I find the standard deviation of this? Somebody tell me. What is the standard deviation to 1 decimal point? Hello, somebody. 1 point what? 1.1 is correct. 1.1 is the standard deviation. By the way, they are asking me for population standard deviation. Notes. That's what they're asking me. So I have to grab this one. 1.1. 1.1. That is because after all, that is the standard deviation after that follows the law of large numbers. After a lot of repetitions, standard deviation that follows the law of large numbers. So that is why I'm going to choose 1.1. What if I'm told to find the variance? Because I could be told to do that in the next question. Somebody tell me how I can find the variance. Let me see if you still remember group there. Somebody tell me, yes, go ahead. Yes, square your 9-digit standard deviation, not just 1.1. Don't forget, square your 9-digit standard deviation. Alternatively, go to VARS statistics, which is 5, choose standard deviation. You want to make sure it is the one you need, yes. Then square it. Then your answer, because your answer is to 1 decimal point, give me your answer. Give me the answer to 1 decimal point. The variance to 1 decimal point. Good. 1.2, any question? Any question? Okay. Well, that looks like a test question. Let's go to another one. That looks like a test question. Okay, let's go to, suppose Aaron, let me grab this and get it out of here. Suppose Aaron is going to build a playlist that contains 13 songs. In how many ways can Aaron arrange the 13 songs on the playlist? And let's see if they said taking all of them at a time. Aaron can arrange that. Okay. And they did not tell us whether it is a combination or permutation. You know, sometimes when permutation or combination is silent, you have to be careful. So let's read the question again and see if they said order is not important. If order is not important, it is combination. It's order. If order is important, it's permutation. So let's look. Aaron is going to build a playlist that contains 13 songs. In how many ways can Aaron arrange it? They didn't tell us. So we're going to get it as permutation. And that is how many, what is it? What is it, somebody? It's 13 factorial number of ways. 13 factorial number of ways, because it's taking all of them at a time. Okay, remember that you can use your calculator. Oh, and by the way, I'm sorry, I like to stop recording for some